The year 2015 marked a watershed moment for the South Korean defense industry, a period characterized by both geopolitical tension and a profound crisis of technological confidence. At the heart of this storm was the KF-X program, the ambitious domestic fighter jet project that sought to propel the Republic of Korea into the elite club of supersonic aircraft manufacturers. The crisis reached its zenith when the United States government officially denied the export licenses for 4 critical technologies requested by Seoul: the active electronically scanned array radar, the infrared search and track system, the electro-optical targeting pod, and the radio frequency RF jammer. International military analysts at the time were largely dismissive, with many suggesting that developing a domestic AESA radar from scratch would take at least 2 decades, effectively dooming the KF-X project to obsolescence or total failure. However, the refusal served as a catalyst for a strategic pivot toward technological sovereignty. The Agency for Defense Development and Hanwha Systems initiated a high-stakes endeavor to prove the skeptics wrong. To understand the magnitude of this challenge, one must consider the complexity of AESA technology compared to traditional mechanical scanning radars. While older systems rely on a physically rotating antenna to direct a single radar beam, an AESA radar utilizes a stationary array of hundreds or thousands of small solid-state transmit-receive modules. These modules can steer multiple beams electronically at the speed of light, allowing a pilot to track dozens of enemy aircraft while simultaneously scanning the ground and maintaining a low probability of intercept by enemy electronic warfare systems. The development process was characterized by the pali-pali culture that defined South Korean industrial success. Between 2016 and 2020, Hanwha Systems and the ADD achieved what many considered impossible: the creation of a functional AESA prototype in just over 4 years. This was not merely a copy of existing Western designs, but a sophisticated system tailored for the specific threats of the Korean Peninsula. A critical factor in this rapid success was the decision to utilize gallium nitride, GaN, semiconductors for the TR modules. Unlike the older gallium arsenide technology used in many early 4th-generation AESA radars, GaN allows for significantly higher power density and better thermal management. This enables the KF-21's radar to transmit more powerful signals and detect smaller targets at greater distances while maintaining a compact form factor. Technical specifications of the production model radar, which began its mass production phase for the KF-21 Block 1 in late 2025, are formidable. The antenna array consists of approximately 1,000 TR modules. In terms of performance, the system is capable of detecting a target with a radar cross-section of, equivalent to a modern fighter jet, at ranges between 130 and 150 kilometers. Furthermore, the radar's synthetic aperture radar mode provides high-resolution ground mapping, capable of distinguishing objects as small as 0.5 meters. This multi-role capability allows the KF-21 to perform air-to-air, air-to-ground, and air-to-sea missions with a level of precision that rivals the most advanced aircraft in the United States and European inventories. The integration phase involved rigorous testing to ensure the hardware could communicate seamlessly with the aircraft's mission computer. To validate the complex algorithms required for signal processing, South Korea utilized a modified Boeing 737-500 as a flying test bed. These trials, conducted between 2022 and 2023, proved that the domestic radar could operate effectively in high-clutter environments and under intense electronic interference. By the time the first KF-21 prototype took flight, the divine eye of the aircraft was already demonstrating reliability levels that exceeded the initial benchmarks set by the Defense Acquisition Program Administration. Economically and strategically, the success of Hanwha Systems has fundamentally altered South Korea's position in the global arms market. The total investment for the radar development was a fraction of what it would have cost to purchase and integrate foreign systems over the aircraft's life cycle. More importantly, domestic production removes the black box restriction often imposed by the United States, which prevents foreign nations from accessing or modifying the source code of sensitive avionics. With full control over the software, South Korean engineers can now update the radar's threat library and performance parameters in real time as new regional threats emerge. The global validation of this technology arrived in May 2024, when Hanwha Systems secured a landmark contract to export AESA radar antenna components to Leonardo, a major European defense conglomerate based in Italy. This was a symbolic victory of immense proportions. The student had become a supplier to the established masters of the industry. The contract, valued in the tens of millions of United States dollars, served as a definitive rebuttal to the 2015 skepticism. It signaled that South Korean AESA technology was not just good enough for domestic use, but competitive on the global stage against established European and American giants. As of early 2026, the focus has shifted toward the production of the initial 40 units for the KF-21 Block 1. The unit cost of the radar has been optimized through advanced manufacturing techniques, ensuring that the KF-21 remains an attractive option for export markets such as Poland, the United Arab Emirates, and Southeast Asian nations. While a high-end Western AESA radar can cost upwards of $5 million per unit, Hanwha Systems has managed to leverage South Korea's world-class semiconductor supply chain to maintain a competitive price point without sacrificing performance. Looking toward the horizon, the AESA technology developed for the KF-21 is being adapted for a wider ecosystem of defense platforms. Plans are already underway to integrate scaled-down versions of this radar into unmanned aerial vehicles and to use the core technology for the K-Destroyer program for the Republic of Korea Navy. The evolution from a rejected technology seeker to a global innovator illustrates a broader trend in South Korean defense: the transition from catch-up engineering to frontier innovation. In conclusion, the story of the KF-21's AESA radar is a narrative of strategic resilience. The refusal of the United States to share its crown jewels in 2015, rather than crippling the South Korean aerospace industry, forced it to mature at an accelerated pace. By mastering the complexities of GaN-based semiconductors and high-speed signal processing, South Korea has secured its place as the 12th nation in the world to successfully develop an indigenous AESA radar for fighter aircraft. This achievement ensures that the KF-21 Boramae is not merely a platform for flight, but a sophisticated sensor node capable of maintaining air superiority in one of the most contested electronic environments on the planet. The eye of the KF-21 stands today as a testament to the fact that technological autonomy is the ultimate prerequisite for national sovereignty.